Well, in today's class, what are we going to talk about is types of chemical reactions. Yeah. In this class, we are going to talk about types of chemical reactions. But before we could do that, is there anyone who can tell me or who can define what is a chemical reaction? Chemical reaction is what? How do we define chemical reaction? Please do that through the chat box. Yeah. What is a chemical reaction? And the second question is, what is chemical equation? Chemical reaction is nothing but a chemical change where the starting materials undergo a change in their chemical composition and lead to formation of an ending material or a new product. Well, the symbolic representation of the same chemical change is called as chemical equation. In this chapter, we have been talking about both chemical reactions and chemical equations, right? Last class was all about chemical equations. We were talking about what are the characteristics of chemical equation, yeah, and how do we write it, what are the parts of it, left hand side, right hand side, physical state, where it has to be represented and all that, correct? And this class and the next class also, we are going to talk about chemical reactions, yeah? When I say chemical reaction, it means we are going to talk about how changes are happening, right guys? Well, there are various classifications. There are many types of chemical reactions in the world. For example, say, I'll tell you the reason why do we have many chemical reactions and many classifications for these chemical reactions. Say you are in a class and your class has around 20 students, boys and girls. Now, if I take that class as an example and if I have to classify them, I can classify them as boys and girls, or I can classify them as taller and short students. Otherwise, I can classify the same group of students as, of course, toppers, slow learners, and average students. Maybe based on skin color, they can be classified. Maybe based on the place that they have come from, the native place, we can classify them based on religion, many more aspects, isn't it? So, a sample of 20 students, yeah, that's correct. Bharat says based on behavior, we can classify them, isn't it? But then observe one point here. Whichever classification we are applying for the same set of students, isn't it? So 20 students can be classified multiple times based on multiple criterions. The same way in the entire universe, we are having chemical reactions which are naturally happening or whatever. But then the same chemical reactions can be classified again and again based on multiple points, based upon multiple criterions. Out of those all multiple classifications, we are going to learn three major classifications in today's class. Yeah. Well, according to our syllabus, three major classifications, right guys? Then let us quickly take a look. What is the first classification about? The first classification of chemical reactions is all about mechanism. But what is meant by the term mechanism? Mechanism is nothing but the process, how exactly reactants are converted into products. Like, for example, if I have milk, after certain reaction, it turned into curd. But how? What has happened in that reaction? How the molecules reacted? How did they change their chemical formula? So this all points are covered under mechanism. Mechanism is exactly how a starting material is getting converted into ending material. So based on mechanism, we have four types of chemical reactions. Number one, combination reaction. Number two, decomposition reaction. Number three, displacement reaction. To be more specific, single displacement reaction. And four is double displacement reaction. Yeah. Well, there are four types of chemical reactions based on mechanism, of which one is combination, two decomposition, three single displacement, and four is double displacement, right? This is the first classification of chemical reactions. But then this is based on only one point, that is mechanism. But I have many other points. I can classify the reaction based on energy, based on oxygen addition or removal, or based on their stability, or based on if they can happen fastly, quickly, or slowly. Yeah. So let us take a look at other classifications also. The second important classification that we are going to learn under our syllabus is classification of chemical reactions based on energy. I hope you all remember the universe is made up of two things. One is matter and the second one is radiation. Radiation is nothing but energy, isn't it? So based on energy transformations or based on energy changes from the reactants to products, chemical reactions can be classified into two types. Type number one is the reaction in which energy is lost, and the reaction in which energy is gained is the second type. So if energy is gained, let me talk about gaining energy first. Yeah, if energy is gained, you call it as endothermic reaction. The term endo means taken in, inside. Yeah, thermic means technically heat energy. Well, the second category is exothermic. Exo in the sense out, given out. Thermic, again technically heat. So if you have a reaction in which energy is lost, you call it as exothermic, energy given out, exothermic. And if you have a reaction where energy is gained, energy is taken during the entire intercourse of reaction, you call it as endothermic reaction. There are two types of chemical reactions based on energy. One is exothermic and other one is endothermic, right guys? Well, we are talking about classification of chemical reactions, and the first classification is based on mechanism. The second classification is based on energy. According to first classification, how many types of chemical reactions do we have? Can I see your responses, please? How many types of chemical reactions? We have 4 types of chemical reactions. Very good. And you see all the names on the screen. And according to second classification, that is classification of chemical reactions based on energy, very smart. I already see the responses. There are 2 types of chemical reactions. Yeah. Now, we have one other classification to be studied, and that one other classification is based on oxygen, based on addition or removal of oxygen, or you can say it as reaction or reaction with oxygen. Yeah. Well, before we could talk about the classification, I would like to tell you why are we considering the reactivity with oxygen as such an important criterion, and we have made a classification and we are studying about it now. Yeah. What is the composition of air? Composition of air is composed of what and what? Air is composed of, okay, Tejal, nitrogen is correct, but percentage, a little more correction needed. Air has gases, nitrogen, oxygen, and other gases. Aditya says, and oxygen, CO2, and other gases. That's great. Air is a mixture, basically, right? It's a mixture of all the gases, of which one is nitrogen, then oxygen, CO2, whatnot, inert gases, SO2 and all that, dust particles, many more. Yeah. And coming to the composition with respect to percentage, the most percentage is covered by nitrogen, that is 78. Then is oxygen, 21. CO2 0.03, and rest everything falls into less than 1% composition. Yeah, right? Well, look at the composition of air. We have maximum composed of nitrogen, but then we are not classifying chemical reactions based on nitrogen, but we are doing it based on oxygen. Why is that? What could be the reason? The reason is oxygen is something which is very, very essential for life and essential for reactions also. Essential for life, we all know, we respire oxygen, isn't it? And without oxygen, life isn't ever possible. Not only human beings, of course, aquatic animals, and every animal requires oxygen, right? Yeah. But then guys, other than the supporting life, oxygen has many other critical roles also in the world. Out of them, one important role is its reactivity. Have you ever noticed the chemical composition of food that we eat? For example, if it is plant derived, it has what? It has cellulose, glucose, starch, carbohydrate, proteins, yeah, lipids, etc., etc. Correct? Observe the chemical composition. What is the chemical composition of glucose? C6H12O6. So other than carbon and hydrogen, there are oxygen atoms also. This way, oxygen is an essential part of every living being as well. And third important factor is oxygen is the most reactive element out of all the components of air. For example, if you ever have noticed metals which are placed in air, they auto get oxidized, like rusting, corrosion, oxidation of iron, oxidation of copper, oxidation of silver, aluminum, whatnot. Yeah, they easily get oxidized. Oxygen automatically reacts with the entities at room temperature. Nitrogen, though its composition is higher, it is very inactive gas. Have you ever heard of something like nitrogen reacting at room temperature with water, or it is reacting with something else? It's too weird. It doesn't react. It doesn't dissolve in water. It doesn't react with anything. So we consider nitrogen to be inactive. We call it as inactive. You know what? When it was discovered, it was named as azote. It was named as azote when it was discovered. Azote means, in the Latin language, azote means something which is inactive, lazy. Yeah, it is inactive. Remember, there is a difference between inactive and inert. Inert gases, they don't react at any cost. But inactive nitrogen, if you heat it up to a limit, if you heat, it gets reacted. Yeah, nitrogen was named as azote when it was discovered because it was found to be inactive. Yeah, any idea who named nitrogen as azote? Any idea who separated the components of air? Any idea? Anthony Lavoisier. Yeah, well guys, so that's why we don't talk about nitrogen. And the second major component of air is oxygen. Since it is reactive and it is essential, we classify chemical reactions based on oxygen itself. Well, based on reactivity with oxygen, there are three types of chemical reactions. One, the reactions in which oxygen is added. They are called as oxidation reactions. And secondly, the reactions in which oxygen is lost, they are called as reduction. And thirdly, the reactions in which both oxidation and reduction happen simultaneously. They are hybrid reactions, and such reactions are called as, very good, redox reactions. Good, Arman and Tahur. That's good. Well, guys, not only them, Samyukta also have responded. Well, guys, these are the three classifications of chemical reactions. The first one based on mechanism, second one based on energy, and third one is based on reactivity with oxygen. Yeah. Now, clearly listen to me. Well, it is an important point also. Okay. If there is a chemical reaction which stands as an example of combination, there is a reaction which stands as an example of combination. It's not necessary that that particular reaction should not be an example of exothermic or endothermic, or should not be an example of oxidation or reduction. If one reaction is falling into one of these three categories, one of these three classifications, it can also belong to some other classification. For example, in that classroom wala idea, 20 students, boys and girls, if I have classified the students based on two criterions, one is boys and girls, second one is the toppers and slow learners. It is not necessary that a topper should not be a girl or should always be a boy. A girl could be a topper or could be a slow learner. The same way a slow learner could be a girl or could be a boy as well. What I mean to say by all this is, one reaction could belong to all the three classifications or two classifications or sometimes only one classification. Yeah, don't assume that one combination reaction cannot be oxidation at all. It could be based on its composition or whatever. A combination reaction can never be exothermic. but they could be, yeah. So one type of reaction of one classification could also belong to some other classification, yeah, right guys? Yes. Well, this is about a brief idea of classification of chemical reactions. I repeat, if you have a combination reaction, that could also stand as an example for oxidation or reduction. Take an example of C plus O2 giving CO2. They are just combining with each other, right? And of course, oxygen is being added. So it can be oxidation also, correct? Yeah, right guys? And of course, this is a burning reaction. So it's an exothermic reaction also, right? Well, if you have understood that point, it would be very clear going ahead. Well, guys, now before we could talk about anything, let me take a pause and ask you, is there anyone who have a question about what we are discussing now? Please do not ask me define combination, define reaction and all that, because we are still not done with it. We are going to do, right? Yeah. So are you clear with the classifications? Are we clear with why are we talking about these classifications? Are you clear about why oxygen is considered but not nitrogen during classification? Yeah. Are we clear? Yes, very clear. Definitions, examples, we are going to talk about. Don't worry. Yeah? Yes? Right then. Shall we go on? Shall we get ahead with the definitions and examples? Sadhana, what's your doubt? Yes, fish respires through dissolved oxygen. Oxygen is dissolved into water. It is just dissolved. It is just a mixture. It is not forming a compound with water molecules. Oxygen remains as oxygen itself, and fishes, not only fishes, aquatic animals respire the oxygen which is in dissolved form. If it is fish, the respiration organs are, respiratory system contains gills. So they respire through gills, and if it is frog, through skin, and of course, the type of respiration depends upon organism, right? Oh God, Sultana, that's what I said. Please don't ask me to explain this combination exothermic, endothermic right now. We are still going to do that, right? We are not done with the definitions, explanations, and also hold on. Yeah. Magnesium by heating magnesium oxide in what? Why is it not possible to prepare magnesium by heating magnesium oxide in Kanishka, can we please do that later? It is something out of syllabus, isn't it? I mean, something out of the topic that we are talking about, isn't it? Yeah. Oxygen is used. Yeah, definitely, Mani. We are using oxygen for the classification. We are considering oxygen for the classification because this is the second important component in the air. First one is nitrogen, but nitrogen is very inactive. It doesn't react with anything. So we don't consider nitrogen's reactivity. And second element, that is oxygen, it is very reactive and essential, and hence we consider reactivity with oxygen to discuss the classification of chemical reactions. And when you go to your class 11 and 12, we also talk about classification of chemical reactions based on hydrogen. Right now we don't have. There are many other classifications which we are not talking about now according to our syllabus. But when you go to your class 11 and 12, there are many more reactions. Yeah, I hope Mani, I'm clear. If not, please update me. Well, why CO2 is not chosen? It is very least, right? I have written the chart with the components. I hope it is visible still. Yeah. So according to that, observe the composition of carbon dioxide 0.03 nominal. So we don't consider that. Yeah. Well, that's great. Now, I don't see any other doubt. Is there any other doubt that's been missed? Any other doubt which has not been addressed? No, right? No? That's great. Then, how is your weekend going on? Today is Saturday evening, and I know it's a little hard for a few of you to attend class at this time exactly. But yeah, how is it going? What plans for Sunday? What plans? Anyone with some special plans or like birthdays or birthday parties? Movie, Mumbai visit? Okay, homework. That is sad, but only. Oh, you had school today. That's also sad. Test on Monday, so your weekend is gone. Pressure, a lot of pressure. Movie with friends, okay. Only studies due to coming exam. Oh, from Monday, studies. Even I had school test on Sunday. Oh God, that's the worst. That's the worst situation, right? It's a Sunday and you have a test on Sunday. Are you prepared then? Because we got leave on Friday for Ramzan. Okay, that's good. Then if you have enjoyed a weekday leave, then no options. Yeah, even I had come across the situations when I was a student, when I was preparing for my JE and all that. It was like too hectic, and every Sunday I had to go to school. I was in 12th, and every Sunday I had to go to school. The first half was a test, was a weekly test, and I used to just get fed up sometimes. If Sunday is test, your Saturday is gone, right? No Saturday, no Sunday, until and unless you finish with your 11th, 12th, and any of your competitors if you are planning for. So I see some of you saying that it is too pressurizing and your weekends are gone or whatever. Yes, my dear students, class 10th and class 11th and class 12th, it is the time span of our life which has to be sacrificed. So I hope you understand. You have to make your mind from now itself that, yeah, you're not going to have big long weekends and all every weekend. Every weekend is not going to be so pressurizing as well. It's a balance here on, yeah, right? Well, guys, then, and even I don't have much plans for tomorrow because I have classes tomorrow as well, right? Well, then, let us continue. The first classification the first classification says that chemical reactions are of four types. 1. Combination, 2. Decomposition, 3. Single displacement, and 4. Double displacement. We are going to understand about each and every term very in detail, and along with that many examples are going to come up. So right now every one of you would require a pen and a book. If you are not maintaining a running notes, please go get it right now. Yeah, and those who are having, that's good. You are all prepared. You are all set. That's good. Well, guys, the first one. In the first classification, we are talking about the first reaction, that is combination. Here on, in chemistry, whatever new words come, try to get the meaning from the word itself. Yeah. So look at this combination. What do you understand from this? You might have heard about a term like combine, unite, mix up, and all that in our daily life, right? Combination. Combination. Why all that? In selecting dresses also we say color combination, correct? It's a good color combination. Or sauce with any junk is a good combination, isn't it? Yeah, with burgers or pizza, tomato ketchup is a good combination, right? So combination is when they are together. Yeah, and here apply the same meaning but a little difference. Combination reaction is a type of chemical reaction where reactants combine with each other. They just get together. They just get united with each other. Yeah. For example, let me take a schematic representation. If A and B are two reactants, when they are reacting, if they are just combining with each other, we call it as combination reaction. This is the most simple definition that I'm giving you. Yeah. Combination reaction, it's a type of reaction where more than one elements or molecules combine with each other to form a new product. Yeah. So in this reaction, whatever is there on the left hand side is reactant, on right hand side is product. Yeah. So after combination, a new product is being formed, isn't it? Well, these combination reactions always lead to formation of a new product. So they are also called as synthesis reactions. What do we call them as? We call them as synthesis reactions. What is synthesis? Synthesis is nothing but manufacturing or producing or forming. I hope you remember the topic you have learned in class 7. Yeah, class 7. Synthetic fibers. Do you remember? Synthetic fibers and plastics. What is synthetic there? Something which is being manufactured, made out of some starting material, right? That is also same meaning, correct? Here also we are having something called synthesis. Combination reactions are also called as synthesis reactions because there is a formation of new product every time. And these combination reactions are very commonly observed. They are a type of reactions which we see around us. How many of you have seen burning? Maybe burning of a paper, burning of wood, burning of coal, burning of garbage. People do, right? People burn garbage. Even if, let me ask you, guys, burning garbage, do you think it's a good idea? Burning garbage is a good idea, is it? It's not, isn't it? Why? Because when we are burning waste materials, we are causing air pollution. We are burning them unwantedly, as a result of which many harmful gases like carbon dioxide, carbon monoxide, sulfur gases are released. They mix up with the atmosphere, they cause pollution. Then what should we do with the garbage if we don't burn it? Should we dump it into the ocean or something like that? Should we do that? No, then it causes what? It causes water pollution. Yeah, non-degradable plastics or non-degradable synthetic materials are eaten by sharks and fish, and out of indigestion they just die, right? It causes loss of aquatic life, and upon that it is polluting water as well. Then what else should we do? Should we just keep it dumped on the soil? That also isn't correct, isn't it? Causes soil pollution. Then what should we do? We should recycle. Of course, this is a biology topic, but still, it's a topic of what to say, if it's a topic of environmental interest, isn't it? Yeah, so always remember not to burn garbage and not to let someone burn garbage. But in olden days, before some 2-3 decades, people were not so aware of these all things, and they used to burn garbage. They used to burn off the leaves, they used to burn off the paper waste and all that without what is that, without recycling or without decomposing them to get manure or whatever. So in those cases, I'm saying whenever they burn stuff, let it be plant derived, animal derived waste, what happens is a huge release of carbon dioxide happens. And in the same way, we burn carbon also as a fuel. Yeah, carbon, a form of coal. Carbon could be in form of coal, charcoal, isn't it? We burn charcoal, correct? Why do we burn charcoal? Anyone? Why do we burn charcoal? Because it's a source of energy, right? Coal and petroleum, class 8 CBSE. Yeah, we burn coal and the energy which is released out of it, where not it is used. It was used to run trains. It is being used to produce electricity. It is used in industry as a source of energy. And why all that? It is also used in ironing. Right now we have electrical irons, but then before this we were using carbon, burning charcoal pieces in the iron box, and we used to use that energy for ironing clothes also. Yeah, well, anyways, this all burning of charcoal or burning of carbon, look at the chemical combination. Look at the chemical combination, what happens inside it. Carbon, when it is burnt in presence of oxygen, they both combine. They just combine, lead to formation of CO2. And of course, we all know this reaction releases a lot of energy. Actually, for the sake of the same energy, we do this, right? Yeah. Burning of carbon in presence of oxygen is an example of combination reaction which is leading to formation of CO2. Of course, it releases energy also. One more, if you remember activity 1.1, magnesium plus oxygen leading to formation of magnesium oxide. Yeah, Mg plus O2 gives MgO. Isn't it a combination reaction? Magnesium is combining with oxygen. Yeah, is this a combination? Right, guys, can I see your response, please? Is this a combination? It is combination, isn't it? And this combination reaction also is releasing energy. Well, observe one point here. Out of these combination reactions, you are having energy also. And any type of reaction that releases energy is also called as exothermic reaction. So burning of carbon and burning of magnesium, they are example of combination, no doubt about it. But at the same time, they also stand as an example of exothermic reaction. Now, is there anyone who is still confused? How come one reaction be example of two types of reactions? Is there anyone Who has this confusion? Please let me know if you have so. No, right? Well, that's good. But just because these two combinations are exothermic, we don't need to assume that all combinations are exothermic. According to our knowledge, these reactions are familiar and we spoke about it. But there are many such reactions which are endothermic as well, which are endothermic until and unless you give it energy, it doesn't happen. Like highly reactive metals, you want to oxidize you want to oxidize slow reactive metals, you need to give energy. Yeah, so always combination reactions are not exothermic. There are many such reactions which are endothermic as well. Yeah, well, let us come back to combination. Combination is the first type of reaction in the first in the first classification. Combination is also called as synthesis, and in this there are two or more than two atoms or molecules or species combining with each other to form a new product. And combination reactions, example C plus O2, Mg plus O, why all this? You can take all oxidations like Cu plus O, Zn plus O. And one more thing, did you notice this? In every case of our example, we have used oxygen. We are adding oxygen. If we are adding oxygen, what can we call it as? Can we call it as oxidation also? Is it possible? Is it correct if I say this as oxidation? So look at these. These reactions are examples of combination, exothermic and oxidation at the same time, right? Yeah? Yes. Well, guys, so this is about combination reactions. Not only this, we come across many combination reactions in our daily life, right? Rusting is a combination, isn't it? How often do we find rusting, right? Well, now, if you have understood, that's well and good. If you have a question about combination reactions alone, please let me know. Is this a skeletal equation? Yeah, the equations are skeletal. I haven't used balanced equations. But guys, whenever you are writing in exams or in your unit test or wherever, ensure that you write balanced equations. Yeah, right? Go in, you are late, it's okay, no problem. Welcome to the class. Please join us. We are talking about types of chemical reactions. Yeah. Why Bogi is celebrated? Bharat, come on, Bharat. We are talking out of topic. Anyways, if you are asking me this because we were talking about environmental concern, yeah, Bogi is a celebration which involves burning of old stuff and all this, right? These all festivals are based on the ancient times, right? So according to environmental concern, we shouldn't be celebrating Diwali, Bogi and all that, correct? It all causes pollution, nothing else. But then it would hurt the feelings of many people if we say that such festivals like Diwali, Bogi are environmentally polluting stuff and it's not good that we celebrate. It would hurt people. So let's not focus much on it right now. Yeah. Yeah, it's all nice. Isn't Diwali nice? It's very nice, enjoyable. But then, guys, we should take a social responsibility also, right? If you have had noticed the environment in your childhood, that means when you were in class 1, 2, 3, and right now, don't you find difference? You find it, right? If you ask me about the environment of my childhood, it was entirely different. And my parents' childhood, your parents' childhood, like, so every 10 years, if you look at it, environment is getting just degraded. And if the same continues, imagine after 100 years, yeah? So it's time, it's high time that we take environmental responsibility and we stop doing all that, right? How many of you here are still bursting crackers on Diwali? How many of you here? You're not, right? Yeah, yeah, Bharat, there were more trees. Upon that, less pollution because less vehicles, less industries, less factories. So the air was fresh and the health condition of people was good. Of course, better than what we are today, right? We stopped 2 years back. Very good, very good. I personally appreciate each and everyone who have stopped bursting crackers on Diwali, keeping environment in notice. Well, even I don't celebrate. I might have celebrated in my very childhood since my dad is very environmentally protective, concerned person. He did not let us celebrate. He never had done that in the childhood also much. Once or twice I might have celebrated. That's it. Yeah. Green Diwali. Right. Green Diwali is very good. Well, guys, In Eid, there is no harm for environment. Yeah, there are many other festivals also where there is no harm, right? For example, Dasara, is there any harm? Until and unless we protect our environment, yeah, Onam, no harm, I guess, correct? Technically improved, right? Technically improved. Well, guys, let's come back. Let's come back. Well, we are talking about what? We're talking about types of chemical reactions, and this is combination. Combination reaction, we have studied with respect to theory, right? So far we have spoken about theory. Now let us take some practical examples and let us understand how does it look like practically. Yeah. Well, how many of you have been taken to chemistry laboratory in class 10 by your schools? Have you gone? Have you gone to the lab? One, two, not it. Okay, yes, yes, yes. Those who have gone to the laboratory must be definitely aware of the apparatus that we use there. And which activity was conducted? Burning of magnesium and zinc plus H2SO4. Oh, Kanishka was absent on that day. That's great. Well, guys, so the same way we have one other practical, yeah? This is one other activity or practical, you can say it as, which will help us understand about a few more properties of chemical combination reactions, yeah? So take a look at this. You have a beaker here. Take 100 ml or 50 ml beaker, and into that beaker, first of all, take water. Okay, so you have a beaker into which you have taken water, and to this water, add a little quantity of calcium oxide. The chemical formula of calcium oxide is CaO, and along with this, we already have water inside, isn't it? They both react with each other. Literally, if this is happening in front of our eyes, we can see the reaction happening. See the reaction happening as in we will be able to see the movement of components in the solution. Yeah, and as a result of this reaction, there will be a product which is obtained, and the product is what? Anyone? The product is CaOH twice, calcium hydroxide. Well, of course, this is an example of chemical combination looking at the theory. CaO plus H2O gives CaOH twice. But then, since we are talking about practical observations, how does it look like? Calcium hydroxide is something which is colorless, so we don't come across a color change in this activity. But then, importantly, if you touch the container, if you touch the beaker, we would be able to find the beaker turning hot as the time passes, releasing heat energy. So if any reaction is releasing heat energy, what do we call that as? We call it as exothermic reaction. The term exo means releasing, giving out, right? Thermic, heat energy. Exothermic is a reaction in which heat energy is released, heat energy is given out. So this is an example of exothermic reaction. But of course, this is also an example of chemical combination reaction. So in this reaction, what are we doing? We are taking water and we are reacting water with calcium oxide, as a result of which calcium hydroxide is formed, and the reaction has been proven to be exothermic as well. But guys, as I told you, it's essential that we write the chemical equations with the physical states, right? So take a look at the full chemical equation for this activity. Calcium oxide, common name of calcium oxide is quicklime, and it's important that you remember this, yeah? And H2O, liquid at physical state at room temperature, leading to formation of calcium hydroxide. Now, this calcium hydroxide which is obtained is aqueous. That means it has water around it, right? And the common name of calcium hydroxide is slaked lime. And one more thing I want to ask you here is, have you ever heard of a term like lime water? Lime water? Not lemon water. Not lemon water at all. What is lime water? Lime water is, it is there in whitewash, correct? But lime water chemically is nothing but calcium hydroxide dissolved into water. So here it is written as slaked lime, isn't it? Here itself, let me tell you one more thing. If you add the slaked lime to water, you call it as lime water. So these three common names are very, very important. And there are many situations where board exams also have used the common names to ask questions. Yeah. So if you are not aware what is quicklime or what is slaked lime chemically, you might miss on 1 or 2 marks. Yeah. Well, guys, calcium oxide is quicklime. Calcium hydroxide is slaked lime. If you dilute calcium hydroxide, you call it as lime water. Out of this activity 1.4, we have CaOH twice, which is formed, which is nothing but slaked lime, right, guys? And of course, this is an example of chemical combination. And there you go with the technical definition of chemical combination. Combination is a reaction in which what happens in combination? Two or more than two atoms or more than two species combine with each other in order to form a single product. Examples, one example of H2 plus Cl2 is there on the screen, but we right now know many examples, right guys? Yeah. And since we are talking about combination and we are talking about this calcium hydroxide, I want to remind one more point here. And that one more point is, actually not remind one more point, I want to ask you a question. How do you detect presence of carbon dioxide? If you are someone who can recall things from your earlier grades easily, you would be able to answer this question easily. Well, I already have an answer from Sai. That's correct. How about others? I repeat my question. How do you detect the presence of carbon dioxide? Using a candle, that's correct. But let me rephrase my question at that case. How do you detect presence of carbon dioxide? With the help of calcium hydroxide. Samyukta, correct. Sai, good. Good, you explained. Janvi, right guys. Carbon dioxide can be detected with the help of burning splinter or burning candle or burning wooden piece. But then with the help of calcium hydroxide, how do we detect it? We detect it, very good, by passing carbon dioxide into calcium hydroxide solution. Take a look at this equation. This is also one important chemical reaction that we should be knowing in both point of view. If you pass carbon dioxide through calcium hydroxide, what happens is they both react, as a result of which calcium carbonate is formed. I just now have told you the color of calcium hydroxide is colorless. It doesn't have any color. If you dissolve it into water, it looks like transparent. Yeah. And if you pass carbon dioxide into that transparent solution, it combines or it reacts, leads to formation of a turbidity, a white colored precipitate will be formed, and at the end of the day it looks like milk. How turbid the milk is. Milk, is it transparent by chance? It's not, right? Yeah, it looks like turbid. It is not transparent. Calcium carbonate, it is also milky when it is formed, and as a result of this, a colorless lime water solution will be turning into milky. This is what is called as turning of lime water milky, and this is formed or this is done due to formation of calcium carbonate. Conversion of lime water milky is done by carbon dioxide, and along with carbon dioxide the same thing is possible even if you pass sulfur dioxide. Yeah, it leads to formation of calcium sulfate. Even then it is a white colored precipitate. So we are talking about two tests here. One, calcium hydroxide with carbon dioxide leading to formation of a milky white precipitate, that is calcium carbonate. Two, calcium hydroxide with sulfur dioxide leading to formation of calcium sulfate, which is also milky precipitate. Remember these two reactions. Have you made a note of this, guys? Yeah, it turns lime water milky, it turns lime water milky. Yes, even SO2 can turn lime water milky. Make a note of this. This is a frequently found question. Yeah, right? Well, that's great. So, well, the reason we are talking about it here is not because it's combination, but because it's important, and we are talking about calcium hydroxide. And there is one more extension for this reaction. If you keep on sending carbon dioxide, then what might happen? You have passed carbon dioxide through calcium hydroxide solution. So it have released into it and it has formed calcium carbonate. But if you keep on doing it, then what might happen? There is a limit for everything, and for turning lime water milky also there's a limit, okay? And if you do that, what happens is if you still pass carbon dioxide into it, calcium carbonate gets converted into calcium bicarbonate, okay? CaHCO3 twice, and calcium bicarbonate is again colorless. It is transparent. So if you pass excess of carbon dioxide, it leads to formation of a colorless solution again. Well, for your clarity, let me just break it down one more time. Those who have missed on it, those who have a doubt, please remember, please focus right now. Yeah, calcium oxide, if you add it to water, leads to formation of calcium hydroxide. This is an example of combination, no doubt about it, correct? And of course, along with this, heat energy is also released, right? This is what our activity was about, okay? But then this calcium hydroxide is an important stuff, and there are many reactions which come around this calcium hydroxide. So those questions are, one, what happens when you pass carbon dioxide into a solution of calcium hydroxide and water? What happens is they both react with each other, leads to formation of calcium carbonate, and along with that water also is formed. The calcium carbonate produced over here is milky or white in color, and calcium hydroxide solution is colorless. So after this reaction, you will find the color change from colorless to milky. This is one reaction. Yeah, are we clear so far? Is there anyone who is lost, who is stuck up in between? Is there anyone? No, right? That's good. Well, now going ahead, you are passing carbon dioxide and calcium carbonate is formed. That's fine. But then if you pass excess of carbon dioxide, that means you have the solution and you are still passing carbon dioxide. It is excess, too much. And then what happens? This excess or too much quantity of carbon dioxide will react with the existing calcium carbonate and will lead to the formation of calcium bicarbonate, CaHCO3 twice. And the color of calcium bicarbonate is again transparent. It doesn't have any color. So if you pass limited quantity of carbon dioxide, it leads to formation of a milky white precipitate. It looks beautiful also. But if you pass excess of carbon dioxide, it leads to formation of a colorless solution again. Why? Because calcium bicarbonate is formed here. How many of you are clear with this? How many of you are clear with this particular equation? This is very, very important equation and question also. Yeah, we are all clear, is it? Right? Right? Well, that's good. That's good. Now, this is all about carbon dioxide and calcium hydroxide. Okay. If you are clear so far, done. Leave it. Now, I have one more point to tell you. And that one more point is calcium hydroxide. It reacts with sulfur dioxide also. The way it is reacting with CO2, it reacts with SO2 as well. And as a result of this, what happens is it leads to formation of calcium sulfate, CaSO4, and that calcium sulfate is also milky in color. Yeah, well, from this, what we need to understand is lime water can be turned milky when you pass carbon dioxide or when you pass sulfur dioxide. Right? Am I clear with what I said just now? Am I clear? Right? Yes, is there anyone who is lost or stuck up still? Is there anyone? No, right? Well, please remember these all reactions. In fact, this all not combination reactions all alone, but we are talking about them because they're important. Yeah, right guys? Well, let's quickly go back to what we were saying. Somebody who asked me for common names are on the screen. Well, combination reaction, example, activity. And of course, it's a reaction where two or more than two species are combining with each other, leading to formation of a new product. Right, guys? And combination reactions could be an example of oxidation or reduction, exothermic or endothermic. Right? Yeah. Is there anyone who wants to ask me a doubt? This is all about combination. After this, we will be talking about the second type. So, if anyone in the class who is lost in combination reactions, please ask me. But remember, please ask me the doubts, whatever we are talking, yeah, whatever we are discussing, right? Why do people consider using CO2 for whitewashing? Consider using CO2, just a CO2 instead of SO2. Okay, that is the full form of the question. Sulfur dioxide is harmful. CO2 and SO2, if you compare, sulfur dioxide is a stronger gas. It's very pungent and it has an effect of harming stuff. It might harm the cells or it might harm the other physical materials as well. It is stronger, but CO2 is milder comparatively. Yeah. White is different and colorless is different. Yeah. When I say colorless or transparent, it's like water. Water is colorless, but milk is white. There's a difference, right? Yeah. But you know, in common life, in daily life, we assume that colorless or white both are same. But when you come to chemistry, you have to indicate both separately. Water is colorless, milk is white. Correct? Yeah. Well, is liquefaction of air is a combination? No, 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 no. It's not combination. It is a physical process. In liquefaction of air, what are we doing? We are applying huge pressure, as a result of which the particles come close and they change their physical state of matter. So liquefaction, evaporation, melting, boiling, they are physical. There is no relation between that and this chapter altogether. Yeah, we're talking about chemical reactions here, correct? Yes. Any other doubt that I missed? Let me just go to the top. If I have missed addressing your doubt, please repost it one more time. While, okay. In the textbook, the solution of quicklime is written for whitewashing. Yeah. Is this the continuation of the same thing? Why do we use quicklime? Why do we use CO2? Why not SO2? But anyways, quicklime, CaOH twice, is nothing but a base. And bases are used as cleaning agents. Yeah. And there is a chapter, the second chapter, acids, bases and salts, where we talk about them extensively. Well, if we react the reactants to get one single product in a combination reaction, we can get one single product. Of course, most of the combination reactions involve formation of one single product. Well, what will happen if we react copper with HCl? Dilute HCl, it doesn't react. Concentrated HCl, it reacts. And I really don't understand why are we talking about copper and HCl right now. Are you suspecting if the reaction is combination? If you are suspecting, but then it is not. It's a other type of reaction. It is single displacement. If we react the reactants to get a single product in a combination, if we react the reactants to get a single product in combination, yes, they will give a single product, like H2 plus Cl2 gives HCl. Yeah, right? Well, Arman, Cu plus HCl, CuCl2 plus H2, yeah, provided it's a concentrated acid. Copper does not react with dilute acids. And the reason it's coming up in the third type of chemical reaction. Right, guys, did I miss on any other doubt? Please help me understand if I have missed addressing your doubt. I'm extremely sorry. Please repost it one last time for me. Second chapter, not exactly in the second chapter. We'll talk about it in the same classification of reactions. Displacement, single displacement. Yeah. Well, let me just tell you the answer for this question is exothermic. When I say respiration, don't only consider the respiration at the lungs level. Yeah, it's only exchange of gases. Respiration is also breakdown of food in presence of oxygen, right? Yeah. So isn't that exothermic? It is exothermic. How many of you have ever felt being very warm after eating a heavy spicy food and not drinking much water? Yeah, if you have had spicy food continuously for 2 or 3 days and you're drinking less water and less water-based drinks, you would automatically find yourself being very warm, right? Yeah, that's all because respiration is an exothermic process. Respiration is of two types if you have studied in bio. One is a cellular respiration, other one is a gaseous exchange, right? So when they ask you for respiration, consider both, and it's an example of exothermic reaction because it releases energy, right guys? And those who are asking me what is exothermic, exothermic is release of heat, yeah, right? It is nothing but release of heat. Respiration is an example of, I know this is a confusing question, yeah, but let me see how many of you would be correct. Are you ready? I know. Why are you confused? You must have been confused with the decomposition reaction. It's clearly seen in the result as well. Respiration, as told, when we say respiration, it's not only gaseous exchange but also the internal cellular respiration. And gaseous exchange, cellular respiration together, if you take, gaseous exchange is not decomposition at all. It's a combination decombination, mixture of both. Then you can't choose option A all alone when we are talking about entire respiration, isn't it? Am I clear? Whoever was confused, yeah, I don't want to reveal your name, but are you clear now? Yeah, right? When we say respiration, we are talking about the entire phenomenon of respiration. So we can't choose decomposition all alone. It's a mixture of both. So respiration is an example of exothermic. Yeah, endothermic, no. Displacement, never. Right? Well, guys, yeah, Shivam, you can ask me your question. And is there anyone else who wants to ask a question now, right now? Is there anyone who wants to ask a question? You can please ask. If you have any doubt, please ask me. Please get your doubts cleared so that it's easy for you to learn. Yeah, if you have doubts in your head and if you are being just quiet listening to me or just watching it like a movie, you're not going to learn it easily. It gets harder for you. So please avoid that. Please interact. Yeah, well, Bharat, please one more time type in your question for me. Do we have more for today? A little more for today. Yeah, guys, I have 2, 3 students who are saying you have doubt. Please let me know what your doubt is right now. What is the example of both exo and homo? Then there is no example of both exo and endo simultaneously. But then I'll tell you why there is no such example. There are some reactions in which energy is given and taken. For example, if you are burning something, okay, you want to burn a paper. Would it burn as it is? You have to make it reach its ignition temperature, right? So you'll initially lighten a matchstick and let it burn, right? That means you're giving energy to it, correct? But then when it is burning, the energy which is given out is too high that whatever energy you have given, it has given back to the atmosphere, and moreover, it has produced a lot more energy, right? So you would be considering the energy whichever is higher. Energy given is higher, energy taken in is higher, then call it as endothermic. Energy given out is higher, then you call it as exothermic. If they both are equal, no, it doesn't happen. First of all, if it is happening, it doesn't fall into this classification, right? Yeah. Well, how can we identify different equation whether the equation is exothermic or endothermic? Yeah, Shivam, that's the right question. By looking at the equation, how do we actually identify something to be exothermic or endothermic or displacement or double displacement? This is something which has to be acquired out of knowledge. Yeah, when you just go on studying through the textbook or any other book, just be noticing the type of reaction. But other than that, I can give you a shortcut. That shortcut is anything which is reacting with oxygen is exothermic commonly, but many exceptions as usual. Yeah, right? Well, how to classify between exothermic and endothermic? I hope I addressed your question as well, Rashmika. Well, combustion is also example of exo. It is exo because you give energy, but then what it has given you back is higher, so you consider what is given back, right? Whichever is higher, you consider that. Yeah, right? Guys, did I miss any other question? You will be having the question on the screen. Don't bother about it. That's already done. Is there any other question that's been missed? Did I miss addressing any other question? If yes, please help me understand. In exothermic reaction, heat is exerted, and in endothermic reaction, heat is absorbed. Absolutely correct. Any example of endothermic reactions? Cooking of food, one versatile example, cooking of anything is endothermic, right? Until and unless we don't cook, we don't give energy, it doesn't get cooked. Somebody who is asking me the definition, exact definition of combination, yeah, I will tell you. In fact, rather than telling you, I'll just open the respective slide. You can take a look at it. Yeah, there you go with the slide on the screen. Right. Yeah, anyone else who is stuck up? No problem, no problem. Burning of anything. Burning of paper, burning of wood, burning of charcoal, bursting of crackers. This all are exothermic, isn't it? But there are some examples of endothermic also. Yeah, respiration is exothermic. Burning candle is exothermic. Any more examples that you can give me? That's good. Melting is exothermic, but then melting, those all things are, let us not, mix up the physical changes and chemical changes. It would unwantedly confuse us right now. Yeah, right? Arman says jealousy is exothermic. That's a very funny answer. Yeah? Burning of charcoal, yeah, exothermic. Burning of anything is exothermic. In total, we can call it as combustion, right? Well, other than that, there are some more exothermic reactions that you should know about, of which one is what happens in sun and stars. Have I ever asked you this question before? What happens in sun and stars? Is this, are they burning by chance? Is burning happening in sun and stars? Okay, Govind, you're right. Anyone else? Guys, come on, you can respond. If your answers are wrong, you don't worry. I'll just not point you out. Be communicating, be trying to answer your best. Yeah. Yes, I see many of you saying that they are burning, but my dear students, you know what? Sun and stars are burning. It's a very common statement that we use, but in fact, it's not true. It's not combustion happening there. It's not burning that's happening there. Shreya, and I would like to appreciate Shreya for answering correct for this. And other than Shreya, it is Govind, right? Both of you correct answers. Sun and stars, in spite of burning, they are participating or they are involving in a type of chemical reaction which releases heat. Exothermic reactions happen inside sun and stars. What is present in sun and stars? Plant, trees, glucose, carbon dioxide, and all that. It has gases. Sun has stars. Of course, stars, sun, both are same, right? Sun is a star, right? Which is actually very close to the earth. Correct? Am I right? Yes. So sun and stars consist of gases such as hydrogen and helium in majority, and there are certain other gases also at a minor level. Yeah. So these gases like hydrogen and helium keep on undergoing nuclear reactions. That means their nuclei when go on breaking down, uniting with other nuclei. It's like nuclear fission and nuclear fusion. As a result of these nuclear reactions, what happens is they release a lot of energy. Nuclear reactions are highly exothermic. So please stop assuming that sun and stars are burning. That means there must be oxygen on sun and stars, or there must be carbon, there must be some combustion happening. It's not combustion, it's not oxygen, it's never carbon. Yeah, it's all about hydrogen helium, the nuclei of hydrogen helium undergoing nuclear reactions like nuclear fission and fusion, leading to formation of huge quantities of energy. How far is Earth from Sun? It's not at least in hundreds of kilometers, it's in thousands of kilometers, right? Yeah. Even at such a distance, even being at such a distance, we are able to acquire such huge energy from Sun, right? Yeah. Then assume how hot sun should be. Most of you know the temperature of the sun's corona, right? It is, I guess, discussed in geography or something. Yeah. And one more thing you should know, sun's corona is an example of plasma, the fifth physical state of matter. Yeah. Plasma, sun's corona, the outer layer of the sun is nothing but plasma. It is damn highly energetic particles of matter. Well guys, sun, stars, they all are not actually burning. They are undergoing nuclear reactions which are highly exothermic, extremely exothermic. And one more thing I would like to add is, have you ever heard of nuclear power stations, nuclear power plants? Maybe before some 5-6 years, there were explosions happened in the nuclear power stations of China, right? Do you remember? And it was too vigorous. It was too vigorous. It killed many people, right? What exactly happens in nuclear power stations? What exactly happens? What exactly happens there is we let the nuclear reactions happen because they are damn exothermic. If you react 1 mole of uranium, the energy which you get is too high, and that energy can be used as electrical energy like something. Even in India, we have, I guess, 2 or 3 nuclear power stations. But nuclear power stations are very, very dangerous. They are very dangerous because nuclear reactions, if the energy could not be handled well, could not be sustained by the equipment, it leads to explosion. And these explosions might just vanish life from countries together. They are very dangerous. Yeah. Like Bhopal tragedy, like Chernobyl, many such things have happened. That's why we don't take a chance with these nuclear stuff. Otherwise, we would be having at least some 2-3 nuclear power stations in every city, right? Because we need electricity too much. But nuclear reactions are very dangerous. We don't use them. The point we are talking about nuclear reactions right now is they are examples of exothermic reactions. Nuclear reactions are examples of exothermic reactions. That's what happened in sun, stars, and nuclear power stations. Yeah, right, guys? And some more examples. How many of you have heard about atomic bomb, hydrogen bomb, nuclear bomb? They are the most dangerous bombs that we have, right? Yeah. Why are they dangerous? Are they so big? Why are they dangerous? Due to their size or shape or something else. They are dangerous because of their explosive nature. Hydrogen bomb, nuclear bomb, or atomic bomb, they are very, very explosive that they can destroy life from a place for years together. If explosion of hydrogen, nuclear, or atomic bomb has happened in one place, there could be no life for years together. It will destroy the place to such an extent. And they are also too exothermic. They release heat extensively within few seconds. That's it. The place is gone. They are damn explosive. There are also examples. Yeah, Hiroshima, Nagasaki, right? Correct? And these hydrogen bombs, atomic bombs, they differ from each other with respect to the composition. Hydrogen bomb, hydrogen is used for nuclear reaction. In atomic bomb, uranium kind of things are used. There's a power cut and you might not be able to see me so clearly. Now it's back, so, right? Well, guys, that's about exothermic reactions. Now, let me talk about endothermic reactions. Yeah, endothermic reactions. Endothermic reactions, by definition, are the ones which happen, which release, which absorb heat energy. Yeah, one example I have told you that cooking of food is endothermic. Yeah, we cook food, that's an example of endothermic. But other than that, can you tell me some more examples of endothermic reactions? No, please do not mix physical changes because it will just disturb your understanding, nothing else. So melting, boiling, evaporation, all that, let us keep them all aside. Fusion, no, it's fusion, fission, both are exothermic. You are not able to see the screen. I have not opened any particular screen, but for you to understand that screen is not stuck, right now I have changed it. Yeah. Endothermic, no, no, no. Other than cooking, I didn't find even one example. I'll give you a hint, okay? Yeah, I'll give you a hint. Ready? It's one such reaction which lets the life exist on Earth. Without that reaction, life isn't possible on Earth. What is that reaction? Money, very good, correct. Tejal, correct. Arman, no. Kanishka, correct example. Very good, most of you, very good. Photosynthesis. How does it happen? What is the chemical reaction of photosynthesis first of all? Photosynthesis is nothing but C6H12O6 formed as a product along with oxygen, and the reactants are what? CO2 plus H2O. The equation is skeletal. And this all happens where? Does it happen just in front of us, in the air or in the sky? It all happens in chlorophyll. And it happens during the daytime in presence of sunlight, right? So if there is no sunlight, no photosynthesis at all. Do you remember this activity done in biology? Must be in class 6 or 7. You will take a plant and you want to understand the nutrition in plants, nutrition in green plants. So you will take a plant, you will just, you will consider a leaf, you will use a black color tape and you will put that black color tape across the surface of the leaf and you will place the pot or you will place the plant in the sun. After 1 or 2 days, when you notice, all the greens would be green, but the surface of the leaf which is covered inside the black tape would not be that green. It would be dull in color, right? Do you remember? Yeah? Yes or no? Very good, yeah. So what does it prove? It proves that photosynthesis doesn't happen in absence of sunlight, yeah. And the same way you can do many more, many such. Just take a plant and put it in the dark room for 1 month. You give it water, you provide the normal temperature, but still put it in dark. It doesn't work. The leaves would be showing a pale color, less chlorophyll, less photosynthesis and all that, yeah. So photosynthesis is a reaction which requires sunlight, yeah. And of course, let it be sunlight or heat or whatever, you are giving it. And if you are giving any sort of energy, you call it as endothermic reaction, right guys? Yeah, so that's about exothermic and endothermic reactions. Let me quickly take you back to the beginning page, the first page of the class. What did we do in today's class? We spoke about chemical combination. We spoke about exothermic and endothermic, right? Yeah, we are done with 3 types. We are done with 3 types of chemical reactions. One is exothermic reaction, endothermic reaction. Third one is chemical combination. So let us stop it here for today. In the next class, what shall we do is we'll talk about decomposition, single double displacement. These are the 3 bigger ones. Oxidation, reduction and all, you can play with it. Yeah, this is about types of chemical reactions, my dear students. Now let me take a pause and ask you, is there anyone who is not? Guys, am I audible? Am I audible? Yeah. Am I visible also? There's a power cut. The video would be a little dull right now. Now it's back, so it should be fine. Right, guys. And yeah, I just forgot to mention the examples provided by a few of you. Have you ever eaten glucose, glucon D, glucose? Yeah. When you take a little quantity, put it on your tongue, how do you feel? You feel it as cold or hot? Sweet is okay, but then other than that, cold, right? Because that is also endothermic. Glucose is immediately taking energy from the cells of your body so that it can dissolve itself. Yeah, that also is an example of endothermic. This way, there are many reactions which are endothermic. I just have not listed them because we don't need to know them right now according to the syllabus. But many such reactions, right, guys? Yeah, so please share your doubts with me right now. And guys, if you don't have a doubt, you can take a leave. Next class, we are going to talk about rest of the chemical reactions. So till here, whatever we are done with till here, come prepared. So beginning of the next class would be questions. Okay. And if you don't have a doubt, please take leave. Have a nice weekend. Those who unfortunately have school and test tomorrow, take it sportively. It's the time that we work hard, right? Class 10, 11, 12, it's the time that we work hard. And if you work hard now, you will be succeeded in life, right? So take it sportive, have a good time, come back to next class prepared. Well, formula of limestone. Limestone is what? Guys, calcium carbonate. We won't have WhatsApp group for physics. My dear, the group is consolidated for all physics, chemistry, bio. Yeah, if you are in one group, it means you are in you're in touch with all the subject teachers. Prepare magnesium by heating magnesium oxide. This question I think I asked you to ask me at the end. Why is it not possible to prepare magnesium by heating magnesium oxide in current hydrogen? Because hydrogen here, I'll write the reaction. It would be better if you look at the reaction. Yeah, we are talking about reaction of magnesium oxide and hydrogen, isn't it? So if you want magnesium all alone, you should have hydrogen combining with oxygen, right? Correct. So if hydrogen has to go combine with oxygen, it should be more stronger than magnesium. But unfortunately, hydrogen is weaker. Because hydrogen is weak, it cannot go fight with oxygen. So it cannot form H2O. If it cannot form H2O, of course, it cannot effectively displace oxygen. So because of high efficiency or high tight chemical bond of oxygen and magnesium, hydrogen cannot let this reaction happen efficiently. That's why we don't use this commercially, right?